My dear students, in my previous video, I have solved some problems in the exercise 7.1 under the topic Applications of Differential Calculus in the 12th standard Mathematics State Board syllabus. I want to say something. The same topic is in the CBS syllabus also. In the CBS syllabus, these applications of differential calculus is given in the first volume in chapter 6. In the CBS syllabus, you can find this topic in first volume, chapter 6, application of derivatives. The topic name is that in CBS syllabus. So you can refer the same problems which I have dealt for this state board syllabus are also useful for CBSE students also. They are also following the same problems and they make use of it. Now I am going to continue the exercise 7.1. The problem number 8 is given. I am going to solve the problem number 8 in the exercise 7.1. A conical water tank with vertex down of 12 meters height was a conical water tank with vertex down of 12 meters height has a radius of 5 meters at the top. See, this is a conical water tank with vertex down. The height of this tank is 12 meters. H. Height of the conical tank is 12 meters given. And the radius, this is the radius, 5 meters. The radius of the conical tank is 5 meters, height of the tank is 12 meters. The vertex at the top, down. A conical water tank with vertex down of 12 meters height of radius 5 meter at the top. If water flows into the tank at a rate of 10 cubic meter per minute, water flows in the tank. Water flows in the tank at the rate of 10 cubic meter. Per minute. Water flows into the tank at the rate of 10 cubic meter per minute. That is, water flows, that is dV by dt. Volume of the water flows into the tank at the rate of its dV by dt is 10 cubic meter per minute. It is given in the book. How fast the depth of the water increases when the water is 8 meter deep? See, when the water is in 8 meter deep, how fast the water flows into the tank? That is our problem. Here, H, what is the radius? R by H. R is the radius. I want one relation. R by height, radius by H. Height is equal to 5 by 12. Radius by height is equal to 5 by 12. From this, R equal to 5 by 12 H. R equal to 5 by 12 H. So volume of the cubical tank is conical tank, sorry. Volume of the conical tank. Volume of the conical tank V equal to 1 by 3 pi r square h. This is the volume of the conical tank. It is the shape of cone. Conical tank volume is 1 by 3 pi r square h, or I can replace in terms of h pi by 12. We want dh by dt. How fast is the water flows when the height is 8 meter height? So dh by dt they are asking. Therefore, we replace r in terms of h. That is equal to 1 by 3 pi r square is pi by 12 h whole square. R is pi by 12 h. Again into h. 1 by 3 pi r square h. That is equal to 1 by 3 pi 25 by 144. 5 square is 25 by 12 square is 144. H square into h is h cube. Okay, this is the volume. Now we want to find out the rate of change of volume when the height is 8 centimeter. The rate of change of volume is that is we want dV by dt, that is equal to 1 by 3 constant, and 25 by 144 is also constant, you can take it out, and pi is also constant. 1 by 3, 25 by 144 into pi are constant, all these things. Into h cube, derivative of h cube is 3h square into dh by dt. 3h square into dh by dt. H cube derivative is with respect to t, h square, h cube is 3h square dh by dt. H is height of the water flows at the rate of 8 meter. So when the height is 8 meter, h equal to 8. So these 3 cancel, you can cancel in these both numerator and denominator. I will get what is it? 25 by 144 pi into h square is 8 square into dh by dt we want. But dV by dt at the rate of this is given by 10. It is given as 10 cubic meter per minute. dV by dt is 10 given. So from this I can rewrite this 10 equal to 25 by 144 pi into 8 square is 64 into dh by dt. 64 and 144 can be cancelled. 8 8s are 64, 2, 16, 4 16s are, you can cancel by 16 double, 4 16s are 64, 9 16 are 144. So you get, you want this is, you will get 25 into 4 by 9 into pi is dh by into dh. After simplifying, 24 into 4 pi by 9 into pi dh by dt. You want dh by dt. So you bring entire things to the left hand side. You keep dh by dt on the right hand side. 10 into, it becomes numerator 9 by 25 into 4 and pi also will it, if you bring it to the left hand side, it became to the denominator is equal to dh by dt. So 2 5s are 10, 5 5s are 25. 1 2 2s are 4. So 9 by 10 pi, dh by dt is 9 by 10 pi. Rate of height is changed at the rate of 9 by 10 pi. So dh by dt equal to, answer is dh by dt equal to 9 by 5 to the 10 pi. 9 by 10 pi meter per minute. So this is the answer. So when the height is 8 meter, the rate of change of height dh by dt is 9 by 10 pi meter per minute. That's all about the problem. So from this you will get r in terms of h. In substitute r square value here 5 by 12 into h. After finding v 1 by 3 pi 25 by 144 h cube. Finding the rate of change of volume dv by dt is this 1 by 3 25 1 by 4 pi or constant h cube derivative is h square dh by dt. Cancelling 3 on both sides, we will get 25 pi by 144. H is 8 given. So 8 square. After simplification, I get dh by dt is 9 by 10 pi. That's all about the problem 8. Next, ninth problem in the textbook. A ladder. See, that's all about the problem. A conical tan, inverted conical tan, with the top is at the bottom, vertex is at the bottom, total height is 12. Okay, next problem number 9. Problem 9 in the next book is a ladder 17 meter long is leaning against the wall. See, this is the wall and this is the ground. A ladder is leaning against the wall. This is the ladder. This is ladder whose length is 17 meter. This is wall and this is ground. You call it ground by x and wall by y. Okay. A ladder of 17 meter long is leaning against the wall. The base of the ladder is pulled away from the wall at the rate of 5 meters per second. This is pulled away, that is dh by dt. The base of the ladder, this is the base of the ladder, it is pulled away at the rate of 5 meters away from the wall. When away from the wall, it is pulled out at the rate of 5 meters. 5 meters per second. And also when the base of the ladder is 8 meters from the wall, when the base of the ladder is 8 meters from the wall. See, this is actually 8 meters. Base of the ladder is 8 meters from the wall. It should be pulled away at the rate of 5 meters per second. So the question is, how fast the top of the ladder moving down? How fast the top of the ladder, if the base is moving away from the wall, how fast the ladder, top of the ladder moving down the wall, we have to determine. That is the first subdivision. How fast the top of the ladder moving down the wall, and the second one is at what rate the area of triangle, the triangle found by ladder, ground and wall, what is the rate, the area of the, what rate the area of the triangle found by the ladder, wall and the floor is changing. The area of the triangle, how fast it is changing. You have to find the second subdivision. So ladder, this is x and this is y, is wall. In the equation, it's a right angle triangle, x square plus y square equal to 17 square. This is ladder, AB is ladder, BC is wall, AC is ground, you can say. Okay. And X square, you know, given is I square, you don't know y square, you determine 17 square. X, 8 square is 64 plus y square equal to 289. 17 square is 289. Y square is 289 minus 64, that is equal to 225. Y square is 225, therefore y equal to 15. Height of the wall is 15 meter. First question is, how fast the top of the ladder will be moving down? The rate of changing the top of the wall, top of the ladder. The rate of changing the top of the ladder moving down is equal to, we want to find out dy by dt. The equation is x square plus y square equal to 17 square. Derivative of square is 2x into dx by dt plus y square is 2y into dy by dt equal to 17 is a constant, 17 square derivative is 0. Substituting 2 cancel on both sides. X dx by dt plus y dy by dt equal to 0. X is 8, dx by dt is 5, y is 15, dy by dt we want, that's equal to 0. So 8 5s are 40. So 15, this is 0. If you bring 15 dy by dt equal to 8 5s are 40, if you bring it that the right hand side, this will be minus 40. So dy by dt equal to minus 40 by 15, that's equal to minus 8 5s are 3 5s are 15, minus 8 by 3 meter per second. The top of the ladder moving downward at the rate of minus 8 by 3 meter per second. Minus sign indicates the moving down direction. Downward direction indicates the minus sign. That's all. The rate of change of top of the ladder moving down in the rate is 8 by 3, minus 8 by 3 meter per second. That is the first solution. Second one is, what is the area, change of area of the triangle formed by a ladder, ground and wall? We will see. Area of the triangle, second solution. Area of the triangle ABC is, area of the triangle is A into of base is X, height is Y, of BH. Area of the triangle is of BH, B is X, height is Y, of XY. So rate of change of area we want, for that we want dA by dt. Rate of change of area means dA by dt we have to determine. Of constant, x constant, y derivative, uv rule, plus y keeping constant, x derivative. uv rule, x into dy by dt plus y into dx by dt. That is dA by dt of into x, you know, 8. Okay, dy by dt is 15. Sorry, dy by dt is minus, dy by dt is minus 8 by 3. dy by dt is minus 8 by 3. Please, y is 15. dx by dt is 5. Okay. Of x is 8. dy by dt is minus 8 by 3 into 15. Y is 15. dx by dt is 5. Simplifying, we will get dA by dt. That is equal to of into minus 64 by 3 plus 75. 5 15s are 75. This is again equal to, if you take LCM as 3, minus 64 plus 3 into 75, 225. So 225 minus 64 is next. So that is 5 minus 4 1, 6 161 by 2 3 are 6. So rate of change of area is dA by dt is minus 161 by 6, or otherwise it is 26.83 what is that, meter square. Area is meter square per minute. So rate of change of area is 26.83 meter square per minute is the second subject. That's all about the problem number 9. One more problem I am going to solve. That is problem, last problem, the exercise 10th problem we will see. The example 10th problem is also in the same manner, same type. That's all about problem 9. Next, the 10th one is police jeep approaching an orthogonal intersection from the northern direction is chasing a speeding car that has turned and moving straight east. See, north is direction. This is north. This is east. This is west. This is south. North is direction. Problem 10 is the car is moving in this direction, eastern direction. 10th problem. Police jeep approaching an orthogonal intersection from the northern direction. Northern direction, from this direction, a police jeep is approaching the car. It is moving in the eastern direction. Car is from B to C in the northern direction orthogonally. So the orthogonal is perpendicularly it intersecting the car's direction as turned and moving straight. The car is moving straight towards eastern direction. When the jeep is 0.6 km north from the intersection, and the car is 0.8 km to the east. Car is 0.8 km in the direction and the jeep is 0.6 km in the direction. Y is and this is X. So it's also given when the jeep is 0.6 km north in the direction, the car is 0.8 km to the east. The police determined with a radar. The police determined with a radar that the distance between them and the car is increasing at 20 km per hour. The distance between the jeep and the car is increasing at 20 km per hour. If the jeep is moving at 60 km per hour at the instant of measurement, what is the speed of the car? When the speed of the car you have to determine. Here also x square plus y square equal to, you consider this is by z, distance between car and the jeep, z square. X is 0.8 square, y is 0.6 square equal to z square. X is 0.8 square, y is 0.6 square equal to z square. 0.8 square is 0.64 plus 0.36 equal to z square. 0.64. 0.8 whole square is 0.64. This is 1.00 equal to z square. So z is equal to 1 only. 1.00 is 1. Z square equal to 1. From this expression I can say Z square equal to 1.00 is 1, therefore Z equal to 1. Distance is not minus 1, it is only magnitude 1, Z equal to 1. And also what is given in the problem? The pole is, what is that? The rate of the pole is determined with the radar that the distance between them and the car is increasing at 20 km per hour. dz by dt given. It is given distance between dz by dt is 20 km per minute. 20 km per hour, okay. dz by dt. If the jeep is moving at 60 km per hour, at the instant of measurement, what is the speed of the car? If the jeep is moving 60 km per hour, jeep moves at the distance of 60 km per hour. So in the equation, you will write x square plus y square equal to z square. Differentiating, you get 2x into dx by dt plus 2y into derivative of y square is dy by dt equal to 2z into dz by dt. The question is how fast the speed of the car. Speed of the dx by dt, they are determined. They want to find out dx by dt. dy by dt is also given 60 km per hour. Speed of the jeep is 60 km per hour. It is given. So 2 cancel on both sides. You will get x dx by dt plus y dy by dt equal to z dz by dt. X, you get what is value of x is 0.8. X is 0.8 dx by dt you have to find out plus y 0.6 into dy by dt is 60. dy by dt is 60 and z is 1 we determined. dz by dt is 20. By finding out 0.8 into dx by dt plus 60 into 0.6 36. Okay, 36 equal to 36.0. 6 into 30, 0.6 into 30, 60 is 36. So, what is that? It is moving down towards the car. It is, you write it as by sign minus. You write it by minus 60 because moving towards the car in the direction is it gives minus 60. You write it as minus 60. So this is minus 36. So 0.8 into dx by dt equal to, already 20 is there. This minus 36, if you bring it to the right side, it has become plus 36, that is equal to 56. So dx by dt equal to 56 by 0.8, that is equal to, multiplying the whole 560 by 8. Okay, multiply both sides by 10, numerator denominator, you will get 70 km per hour. So speed of the car is 70 km per hour. Speed of the car. That's all about the problem. Okay, 10th problem and exercise 1. Okay, I will stop here. We will continue the next topic in the next video. Thank you.